Hello, hello. Today I'm going to talk to you about how we build data models on the Salesforce CTA and all the aspects related to it. My name is Hermanni Toivo. I'm a Salesforce CTA and also a CTA coach. So first of all, what is a data model? A data model is the structure of how we store data in the system, in this case, Salesforce, as well as the other systems if we have data in external systems as well. And it includes the objects, the fields, the records, and the sharing in Salesforce. And basically, it's one of the three parts in the model view controller structure, which is also something that Salesforce is based on. I'm going to talk to you a little bit more about that. So the model view controller is basically this way in which we can break down a system into three different parts. The model part, which is the data model, it's the objects, the fields, the relationships, contains the foundation of what you have in an information system. The view part contains the user interface, the record pages, the list views, those parts in Salesforce. And then the controller part contains all your automations and business logic and any actions that happen on the press of a button, etc. And all of these influence one another. If we don't have a good enough data model, it doesn't make sense for us to build, and sometimes we can't even build the business logic for our system or the right views for our systems because the model is just not correct. And that's why the data model is a really important piece when it comes to the Salesforce CTA. It's one of those things that you must have correct in order to pass the exam. Because let's say if you have an integration mistake, a different integration pattern, well, you can always fix that on the Q&A, but if you start fixing your data model in the Q&A, the ripple effects are just everywhere. So it's really important to have the data model down from the beginning onwards. Okay, so what are the aspects of the data model then that we need to look at on the Salesforce CTA exam? First of all, we need to take a look at completeness. Is the data model complete? Is everything in the data model that should be there? Simplicity. Do I understand the data model? Scalability. What happens if we put a lot of data into the data model and into the different objects that are part of the data model? What happens? Have you planned for that? Have you taken into account the large data volumes? What data is stored externally? Which one's not? And then also the flexibility. So what happens if there's all of a sudden a change in our business logic? What happens with the data model in that case? Can we tack on another object somewhere? Or do we have some sort of hard-coded data in the fields and it's very difficult? We have to evaluate that aspect as well. Because if your data model is flexible, then you can very easily pass the Q&A. So the completeness means that the data model serves all the business purposes and all the business requirements that are set out in the scenario, and that it accounts for all the entities that are there as well as all the relationships that should be there. Now, a bit later on, we're going to talk about how we actually come to the point where we identify all the entities and all the relationships. And then also, the data model should be somewhat normalized at least. So we don't want to go to the full degrees of normalization in the Salesforce necessarily and in our data models, because sometimes we can use things like pick list fields and that, but it should be fairly normalized as well. The data model should be simple. Just by looking at it, I should be able to understand what everything is inside it with a little bit of your explanation. And that means that you need to be able to explain it very easily, but it should also be intuitive if I just look at it. And by what needs to be on the data model, you should have the lookups, the master and detail relationships, and somehow a key which way they're going, which way is the master, which way is the detail object, which object is looking up to which other one. What are the standard objects? What are the custom objects? What are the external objects if they are there? What's the sharing model of all of those objects? And who's the owner of all those objects, as well as any record types, or if you're using person accounts, that type of data, those should be annotated on the diagram so that I can very quickly get a good understanding of it and you don't need to explain to me what it is. You should also have an explanation of what data goes into which object in when you verbally go over the data model. Scalability. Have you taken into account the large data volumes? Do you have some sort of archival strategy for some of the data? And if you do have an archival strategy, is it a feasible one? Because if it's data that we need, then you can't just archive it and not provide it in some other way in the system. Is the data model set up so that you can optimize your queries? If you have business requirements that require you to query from multiple related objects, how are you going to optimize that process? Then also, have you set up your data model so that you can use indexing and the record volumes are low enough in those objects that you don't hit the storage limits? So these are aspects of scalability that you need to take account when to plan when you plan your data model. And then the flexibility. So let's say that your data model, let's say you have hard coded a formula field that calculates the price of something if you have tier 1, tier 2, or tier 3 selected as the product. Now you roll out tier 4, tier 5, tier 6, and then you roll out all kinds of exceptions to how the price should work. Now your data model, which you built, where you modeled a formula field to calculate the price, no longer works, and you need to do refactoring in your data model. How much of this kind of, or how prone is your data model to these types of refactoring needs if there's changes in the business requirements? This is something where in the Q&A, you usually face a lot of questions of, okay, we're going to change this little assumption here. How does your data or how does your solution support it? And then you need to be able to solve that on the fly. So being aware of these aspects of flexibility is very important on the review board. Can it be extended? So let's say that the company, like there are some there could be a scenario where you're asked that, oh, the business requirements are constantly changing and that this needs to be taken into account when you plan the system, which means you need to very clearly state that your data model is very adaptable to whatever those business changes are. And also the flexibility is the sharing requirements. Part of that flexibility. Do the people who need to see the data? And do the people who should not see the data not see the data? So that's also there. Very often, when you're solving a scenario that's structured, business requirements first, and then after the business requirements, the sharing requirements. If you don't take into account the sharing requirements when you're building your data model, when you get to them, you can start over with the data model very often because and you might need to start over because the sharing requirements are very much a requirement into how you build a data model itself. Okay, so the process of data modeling that, and this is a framework that I've come up with sort of which helped me pass the review board. I know there's a ton of different ways that work, but I'm going to share the way that I do this so that you can pass the review board then easier. So the process is that you first identify all the relevant entities in the scenario, whatever they are. They might be things like, okay, we need somehow to represent invoices, we need to represent customers, we need to represent negotiations that we're having with the customers and the stages of the negotiation. It varies by scenario, and we just need to be aware of what we represent. The reason why we need to be aware of the entities and not directly go to Salesforce objects is because there's usually a few different ways we can model everything. We can have a custom object, we can use a standard object, we can use record types of the same object for different business requirements. It differs. And you have to understand all the requirements before you can come up with a holistic solution that you can then defend and justify. Because if just when you first see a requirement, you just say that, oh, wow, yeah, this is good. We're going to use the opportunities for this, cases for this, done. Um, that might not be the best approach if there's other requirements that don't support that decision in the scenario. Then identify the relationships. So how are these things related to each other? Okay, if we're negotiating, do we always have just a single product that we're negotiating about with our customers, or is it multiple products that we're negotiating? What are the relationships? And at this stage, it's more important to just understand that is it one to many to one, or many to many. And that's it. No, not sort of like is it lookup or master detail? That comes later. That comes in the fourth step. But the third step is then we determine the other requirements. Like, okay, we need to store this kind of data about our customers, but only these people should be able to see uh, some sensitive data, but the rest should be visible to everyone. Okay, fine. Then we need to somehow solve for that, whether or not we do it via field level security or whether or not we need to do some sort of uh, other choice then comes in step 4. But in step 3, we determine other requirements than just the entities themselves or the relationships between the entities. So this would be anything from sharing requirements to business logic requirements to different things like that. And then finally, in the last step is where we choose the objects and the relationships that we build. So that's where we actually go in and draw the data model with all the arrows, with all the labels, and come up with the final data model. So I'm now going to show you an example from CD Scooter Share of how to do this. Okay, so we're going to go over some of the business requirements, and then we're first going to highlight all the entities here, and then we're going to write them down because on this actual review board, you get a Google Sheets where I found it really useful to just type these requirements. Then we're going to see what are the requirements for everything and come up with the data model in Lucidchart after that. So first of all, scooter riders must register for the Scooter Shitty program in advance. So we have scooter riders. So that's an entity we have to represent. Must register for the skitty in advance before reserving a scooter. Okay, so there's probably going to be some sort of reservations that happen later on, but this not yet it is not yet a requirement. They should be able to do this from a mobile app or a browser. And they enter their name, address, phone number, and driver license number. So we need to capture these details. Um, and the validity of the and that we need to verify the validity of their driver's license in real time. So and of course we need to get their preferred language here. So looking at that, we need to somehow have a rider which we can capture some attributes of. Okay, so we have a rider with some sort of attributes. And writers can take a photo of themselves, and that's again, okay, they must be able to attach a photo that shows up on their profile. Writers should be able to reserve scooters. Okay, so here we have the reserve and we have scooters. So we need to represent reservations of scooters. So we have reservations of scooters. And then we have the scooters themselves. That's an entity which we have to model. Then if we go back and 1 week in advance using a mobile app or using a browser, riders search for and select a scooter depot. Okay, so scooter depot location. Okay, so scooter depot is here. Scooters and scooter depot. Okay. Got all of these objects here. And then if we move on, the system should then calculate a rental cost estimate in real time using the pricing calculation system. That's an external system. Um, and writers then review rental cost estimates and details of the rental and confirm their reservation. So details of the rental and confirm the reservation. So again, we need some sort of attributes for this reservation, likely things like the price. So we have the price here and we have the depot that should be part. So what I'm doing now is I'm already marking down these relationships. So the reservations of the scooters they are always related to a depot, um, and as they're always related to a rider as well. And then there's a price that is being paid. So because these are relations, I'm going to bold them, and the attributes I'm going to put as unbolded. So here we have the picture of the rider. Then if we go back to the scenario, and the system should generate a QR code that users can use to unlock this at a scooter depot. Okay, so we need to generate a QR code, and the QR code is an attribute of the reservation. Each scooter depot is Wi-Fi enabled and has both REST and SOAP capabilities that can support transfer of data. Thank you. Riders have made a reservation can unlock a scooter and begin their rental by scanning the QR code on their mobile device. Riders can also swipe a credit card and to verify the availability of funds based on the amount of the rental cost estimate. Okay, so here we have a data model requirement that we need to have a payment somehow made based on these. So if I'm looking at this, we need to have payment. And payment is related to a reservation. So I'm going to put here a reservation as such, like this. Okay. And when, so I'm going to put here that we need to availability of funds based on the amount of the rental cost, availability of funds will be here made bold. When a rider returns the scooter, they log into the kiosk and are shown a summary of their rental that includes checkout location, check-in location, total time, um, total mileage, and charge for the rental. Okay, so these are again, this is a requirement. This is something we don't yet know. We don't yet know if we have a reservation and separate rental object, if we have any requirement for that. So we just know that we need to track these details of location, check-in location, total time, or checkout location, check-in location, total time, and these. So these would all be attributes that we have to somehow do later on. So that's why I'm also going to highlight it in yellow because we have to return to this one. The final charge should be sent to the finance application. Okay, yeah. Okay, so I'm going to stop the data modeling process here. Um, I'm going to then now move on to the sharing and visibility requirements where we're going to potentially get some other insights that we need to use for the data model. Okay, so only technicians can change scooter depot details. Got it. So that means that we need to somehow support this in our data model. So the depots will need to be only accessible by the they will only these details can only be changed by the technicians. So I'm going to again highlight this as a requirement that's not strictly part of the data model. Maintenance associates can manually update the availability scooters and that need repairs. Okay, and only these ones. So that's again that's a data model requirement. And for possible theft incidents, okay, we didn't cover theft incidents and those incidents, so we're not going to go over that. Writers can choose to make their contact details public or private, so that's a very important requirement from us from a data model perspective. And repair service managers should not be able to see writers' driver's license details. So repair service managers should not be able to see the driver's license details. Okay, I'm going to not go over the rest of these requirements just to keep this video short because I don't think it's going to add any value. So together with these highlights that we've added here, as well as what we've put into the sheets here, we're now going to build a data model for this, looking at all the objects. So here, considering that all the writers are natural people, they're just people, I recommend that we should use person accounts. I really didn't see anything justifying not to go with them because it's individual people renting out the scooters, not households, things like that. So we're going to have person accounts. So here I'm going to put here that we have account, and I'm going to put that it's a person account. And related to the person account, then we have, of course, always so this would be the rider, this account. And then, well, the rider, we need to have the picture. And then we need to have the driver's license details. So now, considering that they're attaching the driver's license as an image, and my assumption is here that we can use the Salesforce files for it, and there is here a requirement that certain users should not be able to see the driver's license details. Uh, so from that point of view, to me, it makes sense that we have a separate object here called driver's license. And one account can have multiple driver's licenses. And it is this one. And that way we fulfill that sharing requirement. Okay, moving on to the next part in the data model. So then we have the reservations, of course, as an entity, and reservations are always done by the account. It's the rider who's making the reservation. So reservation is being made here. Sorry, like this. Reservation. And one rider can have many reservations if you think about it. And one reservation is always related to just a single rider. So this is the correct relationship. We have the price, and then we have a depot, and then we have the QR code. Okay, so the QR code is just an attribute. It's just a number that gets generated there. Price as well is price per reservation. But something here which we had to note down is the checkout and check-in location. So the checkout location we know because that's the one that they put in the reservation, but the check-in location isn't necessarily the same place where they check them out from. So we sort of we need two relationships actually to depot. That would mean. First of all, let's model the depot object here. So depot can have multiple reservations, right? Because there could be I could reserve many times or somebody else could reserve many times. So let's put that arrow there. Depot has multiple reservations. And in fact, because of the checkout location as well, we need to have a separate relationship for this. So I'm going to note this as in and this as out. Okay, let's take a look at what else we got from here. So we got the scooters themselves. Okay, so the scooters are always at a particular depot, right? So if we think of this then, uh, the scooters, there's always many scooters at a depot. And then later on, when you check out something, you always get from a reservation, you get you get only one scooter per reservation in the end, but that scooter can have multiple reservations related to it. So we have to add that arrow as well to the data model. Because when you check out at one of those depots, you will get a scooter and that will be part of your reservation. But then when you check back in, you'll return that scooter. But there's no possibility to have multiple scooters, and that scooter could have multiple reservations over its lifetime. So that's the correct cardinality in terms of the data model. And then we have the payment. So the payment's done per reservation. So now we have to make an assumption, like, do we have, uh, are we recording the payment attempts per reservation? Yes or no? In general, it's a better idea to record payments as a separate record because sometimes you need to have multiple payments or you need to record failed payments per reservation. Right now, if we were to just tack on the payment information on the reservation itself, that would mean that if we want to change our business logic down in the future so that we're collecting somehow, a payment up front and then a payment later on. Uh, if we, for example, charge for extra time, etc., then we would need to have that as a separate, we would need to refactor our data model. And now, if we think of this potential future requirement, then let's add payment here as a payment related to the reservation. So a reservation should be able to have multiple payments. Okay, so looking at that, so then we have multiple payments per reservation as such. And then let's go over the business requirements then. So that can see the scooter, can change the scooter depot details. That we can take care with field level security and a permission set. So this is not, we don't need to annotate this on our data model. Um, the regional maintenance associates can manually update the availability of the scooters that need repairs. So this is again a field level security. It's also a validation rule that only they can set a scooter to a repair status. So we will have somehow a status on the scooters here. And the contact details such as phone number and email address must be public or private for the riders. So for this one, you have to know that there's a feature in Salesforce Chatter that allows the Experience Cloud users to set their profile as public or private. And for this one, I can see that we can go with this particular feature of Experience Cloud if we're using Experience Cloud in this particular scenario. We didn't touch upon that, but knowing these kinds of details and specifics can help with simplifying the scenario in other ways. And the repair service manager should not be able to see the driver's license details. So if we look at the data model which we've built, this driver's license will be a separate object to account. And this will have to be a lookup relationship, therefore, so that they can't see the driver's license because we'll attach the driver's license related to this driver's license record and as a file. And that way, if you have access to the driver's license record, you will have access to that file. And this driver's license record then has independent sharing of the actual person. So looking at that, we have now established the relationships here. Now the next steps would be we would see like who needs to own which object. Do we need to do some sort of archiving? Do we need to, which ones of these objects do we need to store externally potentially, etc. And which ones we would use standard and custom objects for. So for example, the scooter, to me, it sounds very logical to make that an asset. But asset it requires either a location or it either requires a location or then an account. And that makes perfect sense because the depot could then be the location for the asset. And then the reservation, in this case, I would use a custom object for the reservation. And then the payment would be a custom object as well as with the driver's license. I'm not going to now mark these down for this data model. There's a good video about the CTA diagramming framework by Apex Hours, and that details out how you can make the best diagrams that for your artifacts. Thanks for following the data model exercise. I post almost daily content onto LinkedIn and occasional YouTube videos like this one to help people on the CTA journey. So if you're on the CTA journey or looking to get on it, go ahead and subscribe and connect with me on LinkedIn. to get some more insight. Thank you.